Happy holidays! This is my projectile launcher, the Christmas edition. I will be teaching you guys about kinematics of a particle, and I'll be using this model to show how I can incorporate it into our equations in the kinematics of a particle. So I'm in my room now. Kinematics, what is kinematics? Kinematics is the study of motion with the position, velocity, acceleration, time, distance, height, things like that, without regard to forces. So basically, like forces like friction, air resistance, stuff like that. My project model, I did it in a more confined place where there's not much air that's going to affect it. So the results aren't going to be exactly the same velocity, but it will be pretty close, and it'll give you a general understanding of how the kinematics works. So most people get kinematics and kinetics mixed up with each other. So like I told you about kinematics, position, velocity, acceleration, time, without regard to forces, but kinetics actually has a regard to those forces, and it takes in friction and stuff like that. So I will be showing you how, so like I said, how all the variables, time, distance, height, and that sort affect the velocity. So based on like how far it goes, how high it goes, you can determine the velocity of the projectile. So we will be launching a little Christmas ornament for the holidays. I actually forgot one little thing in my project. About to run to the store real quick, and then I'll be right back. Closer. Start. So we got our 45-degree little diamond because I couldn't find a protractor, so we will be launching at 45-degree angle. So there's the 45-degree angle. Tighten her up. Awesome. So here we have our given values. We have our horizontal distance for the x, 0.22 meters. For the y, we have the vertical distance, which is 0.6 meters, and then the time it took to hit the ground is 0.89 seconds. Alrighty, so we could start off by solving for the initial vertical velocity. Initial horizontal velocity, which would be the horizontal distance equals the initial horizontal velocity times time. So we could just plug these in. 0.22 meters equals VXO times time, 0.89 seconds. We got 0.89, so the initial velocity for the x would be equal to 0.247 meters per second. And since the ball was kicked horizontally, not the ball was kicked horizontally, it was launched horizontally, we will take that, VXO equals VX. So Vx, which is the vertical velocity, or horizontal velocity, equals 0.247. Alrighty, now the next step would be to solve for the vertical velocity, the vertical initial velocity. So the vertical initial velocity equation, we go y, vertical distance equals vertical initial velocity times time minus 1/2 acceleration due to gravity, which is 9.8, times time squared. So t squared. This could be a g too. So we plug in, so we have y 0.6 meters equals VYO times 0.89 minus 1/2 9.8, 0.89 squared, which was the time. So we could solve for this. We'll start right here first. That is equal to 3.881, which is equal to Vy 0.89. So just simple algebra, you know, and bring it to the other side. So add 3.881 plus 3.881. So then we have VYO 0.89 is equal to, what is that? 4.48129. So then we can divide both sides by 0.89 to get the initial vertical velocity. VYO is equal to 5.035 meters per second. Next step, you would want to find the actual vertical velocity, not the initial. Vertical velocity of the horizontal is equal to the vertical initial velocity, Vyo, minus gravity, or acceleration due to gravity, times time. So we just plug that in, 5.035 minus gravity 9.8 times 0.89. And that should give us Vy. So Vy is going to be equal to negative 3.686 in the downward direction. So we have the downward direction due to the gravity, meters per second. And then now that you have your Vy and you have your Vx right there, you can just do vectors addition. Vectors addition is V squared equals Vx squared plus Vy squared, or vice versa, however you want to do it. So we just plug those in. So Vx squared, so we have down here, up here we have 0.247 meters per second squared plus, and then we have our negative 3.686 squared. So now after you do this, we'll put that on my calculator, 0.247 squared plus 3.686 squared, which that is equal to 13.6476. And now you take the square root of that, so you get the velocity, and then the square root. I'm about to do this on my calculator. We have, this is not my calculator, so I need to find everything. Where is the square root? Oh, there it is. Alright, so square root, clear, square root. Where'd that answer go? Alright, 13, so 13.6476. So we just square root it. Whoa there. I gotta close the parenthesis. So that is EV is equal to 3.69427 meters per second, and that is the overall velocity of the launch. So now, as you can see how all the math works out, how each variable, the x, y, time, velocity, are all part, or how do I explain it? Can all help you solve for velocity, or each one, horizontal distance, vertical distance, time, depending on what variables you have. So if you just have velocity and time and vertical distance, you just have to plug everything in to these equations. Right here are the main equations for plugging in. And then now you can see how each variable takes part and how it can change the outcome of the velocity or time or whatever you're solving for. So those equations, all the math and stuff was for the second and third year engineering students. If I were to present to second or third year college students, I would somewhat explain it similarly. I would definitely show the model more. I would show more models and how it's more applied in the real world, how kinematics is applied in the real world, just so they get a basic understanding of how it works, how kinematics works in like certain products. I would definitely show them how the math works and how like each variable is can change the effect of the velocity or the time and things like that. And I'd like to say thank you for listening to my presentation. If you liked the video, like, subscribe, and comment below.